This one is slightly different again. Form is very similar, but there are only two brackets, and you'll notice that one of them is squared. Now that tells us that I have got a turning point on my x-intercept, because this squared thing looks like a parabola. Okay, so I've got one of my x-intercepts touches my x-axis, and one of them cuts it. Okay, so from our form we can actually get a pretty good idea of what this graph looks like. Okay, so in the form, and we don't need to expand it into our x-intercept form, it's already in x-intercept form, it just tells us I've got a turning point on my x-axis. So in the form y equals a, x minus x1 and x minus x2 all squared. I look at my a value, well that's less than 0, so I know that this thing starts up and goes down. My x-intercepts occur when y equals 0, so we have 0 is negative 2 x plus 1 x plus 4 squared, and we have a null factor law, and we have that x equals negative 1 or x equals negative 4. And it's probably a good idea to just give yourself a little note there that cuts, because it's linear, and that's the one that touches because it's quadratic. It'll help you when you are sketching. Okay, we need a y-intercept, so y-intercept when x equals 0, so we have y equals negative 2, 0 plus 1, 0 plus 4 all squared, so that gives me negative 2 times 1 times 4 squared, and that's 16 times 2 is negative 32. All right, let's sketch this. So our x-intercepts were all negatives. 1, 2, 3, 4, that'll do. And we've got negative 32 on our y-axis. Okay, so we have 0 and negative 32, and we have negative 1 and 0, and we have negative 4 and 0. We're going to get a turning point here on our x-axis, and we're going to be putting another turning point somewhere there. And we're going to be sketching a nice neat graph. So notice we've got one turning point on our x-axis, and like that. And that's y equals negative 2 x plus 1 x plus 4